Hi, hello students. Welcome to my channel, Wonderful Physics, to learn something wonderful, to learn something in depth about the concepts of physics. In the last lecture of oscillations, we studied about the time period of oscillation and basically why does oscillation take place? What is the reason for oscillatory motion? We saw that. You can watch the last video of this uh, lecture series where I have explained why does oscillation takes place. What is the factor that causes oscillation? So the main factor that causes oscillation is the stiffness of the material or the inertia of the material. And it is a very interesting topic. When you displace the body from its mean position or equilibrium position, a restoring force acts to bring back the body to its original position, and this causes oscillation. There is a balancing of forces. This force tries to bring it back to the natural position. And that's how the oscillation takes place. We studied what is the concept of time period. It is the time required to complete one oscillation. Now another very important concept, another term that is used to describe this oscillatory motion is the frequency. Frequency in the most general sense, it is defined as the number of oscillations that occur per unit time. Generally, the number of oscillations per second is defined as the frequency of oscillation. How many oscillations are occurring per unit time per second is called the frequency of oscillation. And this frequency and this there is another term, wavelength. We will come to that discussion also. They actually characterize the different types of waves. For example, frequency of electromagnetic waves is a very important factor that differentiates many electromagnetic waves. They all have same speed, but their frequencies are different, so their definitions, their properties are also different. For example, X-ray is an electromagnetic wave, and visible light is also an electromagnetic wave, but their frequencies are different, so their properties are different. Mobile communication occurs with the help of radio frequency waves. They have different frequencies. Gamma rays, they are also electromagnetic waves. They have different frequencies. Frequency is a term that characterizes different types of waves. That characterizes the different types of waves. For example, the waves in the electromagnetic spectrum. When we say spectrum, then it means different frequencies. When you observe the light that is passing through a prism, and that prism, it separates the different lights, different wavelengths, and what we observe is a band of colors which is called the Vibgyor. And this band of colors, it is nothing but the different frequencies emitted from violet to red. Again, there is a characterization which is wavelength. We will come to that section later about that wavelength. So frequency differentiate different types of waves. For example, the audio signal or the audio waves, audio I should write sound waves, have a certain frequency which ranges from 20 hertz to 20,000 hertz. This is the range of the audible frequencies, audible sound. We can hear these sounds. We can hear the sounds that have frequencies ranging from 20 to 20,000 hertz. This is the audible range. Beyond this, beyond 20,000 hertz, you have ultrasonic sound, ultrasound. Beyond 20 hertz, before 20 hertz, there is the infrasonic waves that are that are not very common, and they have different interpretation, the different method to detect. Our ears can detect sound in the frequency range 20 hertz to 20,000 hertz. So this is defined as the frequency of oscillation. So let us come to our point about the simple harmonic motion. Frequency is simply the number of oscillations that is required or that is occurring in per unit time per second. And in general case, what we do, we represent frequency by a term called angular frequency. We represent frequency by a term called the angular frequency, and we denote it by omega. Now this angular frequency, it is just not a different term, but it has certain mathematical meaning, and it is related to periodicity. We denote frequency by angular frequency, or we use angular frequency omega because it is in the analogous case of uniform circular motion. It represents the number of radians that is swept per unit time, and this is a very important concept. This angular frequency represents the analogous case of uniform circular motion, and we will see how does this circular motion is coming into play. In case of uniform circular motion, represents the number of radians that is swept per unit time, So we represent this by angular frequency omega, and we have the mathematical relation also. The mathematical relation is omega is equal to 2 pi nu. Omega is equal to 2 pi nu. In general, the frequency is nu. So this is how we represent the frequency of oscillation. And what we observed in the previous class, frequency is related to the ratio of the spring constant to the mass. In the last lecture we saw this. So it has an in-depth meaning, and we will see what is the meaning, how does this frequency come. The frequency in case of the oscillatory motion is the ratio of the spring inertia K and the mass inertia M. This is the ratio which defines the frequency saw in the last lecture. Now let us first define what is the most simplest form of this oscillatory motion. What is the simplest form of oscillatory motion? Oscillatory motion, we know, we have defined in the last lecture that oscillatory motion is the to and fro motion. The body is moving to and fro between its about the mean position, about the average position, about the position of equilibrium. The simplest form of oscillatory motion, the simplest form of oscillatory motion is the simple harmonic motion. Simple harmonic motion. Now let us first understand what is the meaning of these terms simple harmonic motion. Simple harmonic motion, we know what is motion. Why it is called simple harmonic? What is the meaning of the term simple harmonic? Let us come to that point. Simple. In the last lecture, we saw that when the body is displaced from its mean position by some amount x, then what happens? A spring-like force acts on the body, which is called the restoring force. It acts on the body to bring it back to the original position. And this force, spring force, is proportional to the amount of displacement from the mean position. This force varies as the first power of the displacement from the mean position. So this is called a simple harmonic motion. If we take angular case, in that case x is replaced by theta, angular displacement, and in that case also the force is proportional to the first power of displacement, first power of angular or linear displacement. So it is called simple harmonic motion. Why it is harmonic, I am coming to that point. When the body is displaced from the mean position, then the restoring force acting on the body, which is the spring-like force F equal to minus kx or minus sx, whatever you say, is proportional to the first power of the displacement. In case of angular motion, the force is proportional to theta. There is no term of theta square or x square or y square, whatever be the displacement. So this is called simple harmonic motion. This is the simplicity. This is why we say it simple harmonic motion, proportional to theta. In any case, the force, or I should write the restoring force is proportional to the first power of displacement from the mean position. So it is called simple. This is the reason we say it is a simple harmonic motion. This is why we use this term. because it is proportional, the force is proportional to the first power of displacement. There are no higher powers of x or theta present in the expression of force. This makes it simple. And to then what is the condition for simple harmonic motion? The condition for simple harmonic motion is that the displacement of the body from the mean position is small. This smallness is also defined in mathematical terms that I will come in this section or later in this section. What is the meaning of this small mathematically? This means that when the body, when the displacement of the body is small from the mean position, or in other words, which is mostly found in the books, or in other words, there is slight displacement from the mean position, then the oscillatory motion is called simple harmonic motion. Is called simple harmonic motion. This means if you have a pendulum and you are displacing its bob very slightly from the mean position, your oscillation will be simple harmonic. But if you are displacing the bob from the mean position to by a large extent, by a large amount, your oscillation will not be simple harmonic. The next term in the definition is the word harmonic. Harmonic means, what does this harmonic means? Actually, it is related to the harmonium, the instrument, musical instrument, and music is all about physics. Harmonic means the motion or the displacement is described by periodic functions, periodic mathematical functions like sine and cosine. Tan and sec, they do not define the periodic motion. Harmonic. The motion or the displacement of the body from the mean position is described by harmonic or periodic mathematical functions like sine and cosine. So it is called harmonic. Periodicity is there, periodic functions are required, so it is harmonic motion. So this is the meaning of simple harmonic motion. So in the most common form or the simplest form, we can describe that simple harmonic motion is the most simplest form of harmonic motion or oscillatory motion, where the body is displaced from the mean position. The restoring force is proportional to the displacement and directed opposite to the displacement of the body from the mean position. That is why we have a negative sign. In the most simple manner, we can describe that the simple harmonic motion, SHM, is the motion in which the body, when displaced from its mean position, is acted upon by a restoring force, which is proportional to which is proportional to the displacement from the mean position and is directed and towards the mean position or towards the or not towards or away from the direction of displacement. This is the definition, this is the way we define or describe a simple harmonic motion. The important condition is that the restoring force, it must be proportional to the displacement from the mean position, and it should be directed towards the mean position in direction opposite to the direction of displacement. So what we observe, that in a simple harmonic motion, since the restoring force or the spring force is proportional to the amount of displacement, it is the region where in a body a law is followed, and that law is called the Hooke's law. The force, restoring force, when it is proportional to the displacement, we define in elasticity the Hooke's law that strain is proportional to stress. So the stress is the restoring force and the strain is the change in the configuration of the body. Here it is the displacement, amount of displacement from the mean position or average position or equilibrium position. So SHM occurs in a region where Hooke's law is followed. Hooke's law is followed, which means that the restoring force is proportional to the amount of displacement. The restoring force is the stress and the displacement from mean position is the quantity analogous to the strain. So as long as this Hooke's law is followed, the motion is oscillatory simple harmonic motion. Beyond this, when the Hooke's law is no longer followed, when the strain or the displacement is proportional to x square or x cube or when the force is proportional to the second or third or fourth power of the displacement, in that case the motion is not simple harmonic. Then it is described by some other techniques. As long as, I should write it like this, as long as the force is proportional to the first power of displacement, the motion will be SHM, simple harmonic motion. Beyond this, if f is proportional to x square or x cube or theta square or theta cube, the motion is not simple harmonic. So this is the simplest case of oscillatory motion, simple harmonic motion. Why it is simple, I have told you. Why it is harmonic, that also I have told you. Now let us come to the topics that we have planned to discuss in this lecture. This is the definition of SHM. Now, how the most important question when we are studying oscillation or simple harmonic motion, in general, whenever we say oscillation, the first thing the only thing that is described is SHM, simple harmonic motion. Apart from simple harmonic motion, there are other types of oscillations also. Damped and forced oscillations, that are the topics to be discussed in the later lectures. So the basic form of oscillatory motion or vibratory motion is the simple harmonic motion. The most basic and the common form of oscillation is the simple harmonic motion. This is the most common form of oscillation. So we are interested in this topic. So we are studying this topic. Moreover, there are other factors how this simple harmonic motion is related to the material, to the atoms inside the material, and what are the details we will see. So whenever we are describing this oscillatory motion or SHM motion, simple harmonic motion, there are certain quantities that are required to be described, or they are necessary to describe the motion, because this oscillatory motion is something different from the types of motion that we have studied previous to this oscillatory motion, linear motion and rotational motion. Here you have oscillations. We have defined oscillations, the to and fro motion. This is a different kind of motion from translatory or rotational motion. So certain quantities are required to describe this oscillatory motion, and the most important concept is the phase, that is the heart of oscillatory motion and wave mechanics. Anything that is related to waves, starting from the alternating current that is supplied to your homes and classrooms, to the quantum systems, to the electron microscope, and to the quantum mechanical systems that are described by another wave equation, which is the Schrodinger equation. To describe the oscillatory motion, the most important term that needs to be understood is the phase. We have heard this word phase many times, but now we need to know what is the concept of phase. What do we understand by phase? Again, let us start with one example of this oscillatory motion, or the simple pendulum, which is the most common form of oscillatory motion. Let us consider the case of the simple pendulum. You have this diagram here, or let me show you another diagram to get a clear idea. Let us use this diagram. All these things are provided in the notes. You can get these notes from the description of the link description that I will provide, and from the website that I will provide. So this is a simple pendulum. We all know this is the most simple case and the most common form of oscillation that we study. In the last lecture video, we described time period and we described the extreme positions. Now you see there are two positions on the right and left of the mean position B. The mean position is the point B, and the extreme positions are the points A and C. Now the question is, now extreme positions, they are at equal distance from the point B. The points A and C are at equal distance from the mean position B. Now if I ask you, or if someone asks you a question, how do you differentiate the points A and C, or how do you distinguish mathematically the points A and C? You will say the A is on the left, C is on the right, but how to describe this left and right mathematically? This is the question. So we have this question: how to how to distinguish the points A and C. They are at same distance from the mean position B. Or the question may be how to represent the points A and C. And this introduces you to the concept of phase. I will not come to phase directly right now. Now the question is that how you will distinguish the points A and C. We will say that the points A and C are at left and right of the mean position B respectively. This is what we will say. But how to represent this left and right, how to express this condition of left and right? So this is the question. This requires the introduction of another quantity. How to represent the left and right positions mathematically. Now this brings you before you, this will remind you of two concepts that you have studied in your basic physics. One is the vector, another is the complex number. I will come to complex number later. In vectors, what we do? What are vector quantities? Vector quantities are those quantities that have magnitude and direction, and they follow the vector law of addition. So if there are two quantities of same magnitude, two velocities of same magnitude, one is moving towards right, another is moving towards left, with respect to a defined origin or with respect to a reference point, we denote them by signs, vector signs. We differentiate them by directions. So we have to apply a same methodology to describe or to differentiate these 2 points A and C. In case of vectors, we represent two vectors of same magnitude but in opposite directions with respect to a reference point by different signs or vector notations. In the same manner, you will differentiate these 2 points A and C. In the same manner, in this case of oscillation, in this case of SHM or oscillation, anything, we distinguish A and C by a quantity called phase. or phase angle. This is the quantity that distinguishes A and C. So let us first come to the definition of phase or phase angle. Phase or phase angle is a quantity that completely describes the motion and the position of the particle, of the oscillating particle with respect to the mean position or equilibrium position, and this equilibrium position is our reference point. We are describing the points A and C with respect to the mean position or the equilibrium position. It is the reference point with respect to which we are describing A and C. We are differentiating A and C. So this is this is called phase angle because generally it is represented in the form of angle. You can represent it in terms of time also. So this phase differentiates the 2 points A and C. In the above case, we say that points A and C, they are 180 degree out of phase. They are at 180 degree out of phase. They are moving opposite to each other. For example, in the above case, we say that the points A and C are 180 degree out of phase, or they differ in phase by pi 180. Differ in phase by pi. So this pi or this 180 degree, it shows the relative relation, relation between the 2 points A and C. How do the points are different? How we can represent these 2 points mathematically? If we represent point A as 30 degree, then point C is 180 degree out of phase from the point A. This is the definition of phase of a system, for phase of an oscillating particle. So how this phase is represented? This phase has to be represented in terms of an angle. That is why we call it a phase angle. That is why we say it phase angle. And in general, the representation is in the form of the argument of the sine or cosine function. So for the time being, let me give the snap of the expression. The phase or the phase angle is represented by the argument of the phase of the sine or cosine function. As I said, this oscillatory or simple harmonic motion is represented by harmonic or periodic functions, so we are using this sine or cosine. So the general form is this. This is how we represent the phase. Sine A sine theta, theta angle omega t plus phi naught. From the equations of motion in circular motion, you must have studied theta means angular displacement omega is angular velocity, t is time, plus phi naught. This phi naught in the brackets is a condition, is a situation that defines, that is why it is called a difference. So let me first write this theta. We have this theta is equal to omega t plus phi. Omega is the angular velocity. Omega is the angular velocity and t is the time. Now this quantity phi naught, it has a special meaning. Phi naught is generally called the angle of epoch, and it describes the phase of the particle at the initial time. The quantity phi naught phi naught is the phase angle at the initial time, t equal to 0, and is called the angle of epoch. So this phase angle, or this phase, it, as the definition says, it describes the motion of the particle, the position of the particle at a particular instant with reference to the mean position. In the above example of the simple pendulum, if we have to describe the point C, we will say that the point C is at a particular time. At this position, it has this kind of motion, and all this information is contained in the phase. I will show you the phase, concept of phase, in the sine function also. So the phase, the phase is the quantity that completely defines the state of the particle in terms of the position and momentum, position and motion with respect to the mean position, This is the concept of phase. This is how we define phase. This is the use of phase. For example, let me show you with some diagram a simple sine function. Let us understand the, so things will be much easier to you in the later sections. The concept of phase in terms of a sine function curve. So let us try to understand this. So here you have a sine function curve, the graphical representation of sine function. Now let us see what is the concept of phase and what is the concept of mean position. This one is the mean position, the zero position. This is the mean position. Mean position. Now try to understand the concept of phase, how it is related to this angle. Now let us come to the first peak, which is the positive peak of this sine function. And this one is the first positive peak. Let us denote this peak by A. A, which is the positive peak of the sine curve. And then in a similar manner, you have this negative peak of this sine function. Let us denote this by B. This is B, the negative peak of the sine function. Now the magnitude of these peaks, the heights of these peaks with respect to the mean position, let us this mean position we denote this by O. The heights of these these peaks with respect to the mean position, they are same, the magnitudes are same, but their direction is opposite. One is towards the positive, other is towards the negative. Now this is a sine function. We know the sine function, sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 it is minus 1. So what is the difference? How do we distinguish these 2 points A and B? They are out of phase by some angle. If you want to understand this in terms of the angles, so we see the circular projection here. We see the circular projection. This is called the circular projection of SHM. So if we represent this sine curve on a circle, it has 2 pi radians. So the mean position is at 0, or this is the mean position where the particle is. When the particle is at the mean position, it is the initial state. To understand, let us understand the concept of phase by relating the sine function curve with a circle. A circle means 360 degrees. 360 degrees of angle. 360 degrees of angle. Now if you extend this point to a circle, it comes to pi by 2 or 90 degree. Point A comes to the pi by 2 or 90 degree, and point B is at 270 degree. And what is the difference between these 2 points in terms of angles? It is 180 degree. So point A and B are 180 degree out of phase. If there is a point on the positive axis, similar as that of A, point A and that point have same phase. In the diagram, we see that the points A and B correspond to the positions 90 and 270 degree on the circle. So these 2 points that are at same distance from the mean position, but are at different sides of the mean position are separated in terms of phase by 180 degree, or there is a phase difference of 180 degree between A and C. This is how phase is used. This is the concept of phase. The literal meaning of phase, because this is a quantity that we should understand very clearly, because as I said, it is the foundation of the entire wave mechanics. If you want to study this higher concepts, then understanding phase is very necessary. Not only higher concepts, if you want to understand AC, alternating current, alternating voltages, phase is the most important factor that you have to understand. Phase means a state. What is the meaning of state? Means what is the description of the particle with respect to the mean position or with respect to the equilibrium position. How this particle is defined compared to the equilibrium position. So at point A, we see that the particle is at some height, or it is at some distance away from the mean position in the upward direction, and in case of B, the particle is displaced from the mean position in the downward direction. And this is how we describe these two situations at A and B. We relate A and B by a phase angle of 180 degree. The points A and B are related to each other by a phase difference of 180 degree. This is the concept of phase. There are terms we come across in case of wave studies related to waves. Same phase, opposite phase. So here we see that the points A and B are at opposite phase. Their states are opposite with respect to the mean position. We relate this to the wavelength, and that is the most very interesting topic. It explains the phenomena of interference and diffraction. The points A and B are said to be in opposite phase as their phase difference is 180 degree. If they are at same point, suppose I draw here a similar pattern. Suppose I draw it like this. The drawing is not very appropriate, but for your understanding it is sufficient. And now I denote this point by C. Points A and C, they are at same phase. the points A and C are at same phase. And if I denote this point as D, this point as D, similarly B and D are at same phase. Their state is same with respect to the mean position 0 or the equilibrium position. So this is how we describe phase, and it is the most important concept in simple harmonic motion or in oscillatory motion or in the study of vibration quantities. So if you require the PDF notes, they are all here. Whatever I teach you, you can get it from the link that I provide in the description of the video. And please do like, share and subscribe for the sake of physics, for the sake of learning and teaching. And please tell me your requirements in the comment section, what you want to know, what you want to understand. If you want something to be repeated, then I will see to it. I will explain it to you again. Thank you.